friends. Today our lecture will be given by Dr. Ratna Trivedi. She is a HOD in Department of Environment Science, SRKI, Surat, and she has done her BSc in microbiology, MSc in microbiology, and she is a gold medalist from North Gujarat University. And she has done also her MSc in ecology and environment science. So she is actually a double postgraduate in science. She also has done her postgraduate diploma in ecology and environment science, PGDMLT and PhD from North Gujarat University in the subject of microbiology. So she has a lot of expertise with microbiology also, environment science also, ecology also. So it has all mix of all three important area of environment science. Then she has also a PhD and MPhil guide here at SRKI. So she guides students for PhD also, MPhil also, and she has more than 31 paper international and national board and published in the international and national journal of repute. And she has a member of editorial board in number of journals, and the notable journals are International Journal of Environment and Technology and American Journal of Microbiology. So I think that she is an expert in all this subject of microbiology and environment science, and we are glad to have her among us. So I request her to take a lecture on bacterial growth. Thank you.
Good morning all. As you know that from many days that you are studying with a growth pattern and many other part of microbiology, right? But what you have been covered till today, that is growth of microorganisms, right? But we need to study the growth of microorganism in another pattern which is required in a biotechnology. That is, in fermentation technology, growth is defined, or growth is need to study at two different aspects. One, that is batch cultivation, and second, that is continuous cultivation, right? So my area for this particular lecture, we are going to study the growth pattern to make it according to the desire of the industries. We will make it in a synchronicity, and that will going to help industry as well as in research. We need it in a same phase of the growth pattern or in the growth cycle, right? So that is we are going to cover today. Growth is defined as a cellular constitution, and that is increasing, that the result of it increasing the microorganisms, maybe in the size, maybe in the population, or maybe in the both, right? So normally what you haven't studied, that is microorganisms have growth at 4 different phases, right? Lag phase, log phase, stationary phase and decline, right? That you already studied this thing. Now we are going to incorporate the whole thing, that is while the lag phase, what will happening during? What happening during the lag phase is? They are adapting to the environment, right? They are adhering, they are trying to make themselves acquire with the environment, right? If it is whatever the broth, whatever the media, the organisms are making themselves acquire with. During that, what will happening? That they are continuously producing, they are continuously synthesizing their own enzymes, right? They are doing it with that cytoplasmic activity. After that, suddenly the size, the population is going to increasing, right? Why the thing is happening? How you can come to know that growth is increasing? The organism will come into the log phase. Okay, what is the role in the log phase? What will happening in the log phase? Okay, now in the same time, if we will put whole the thing in the closed system, okay, organisms are there in the closed system, okay, population will remaining in exponential for both generation as well as to enter into the stationary phase. Okay, what will happening during this stationary phase? Normally organisms will utilize the whatever the nutrient is surrounding to them, that is during the log phase. Okay, But as they are entering into the stationary phase, organism will start to produce their secondary metabolites. Okay, various type of the secondary metabolites will produced by the organisms, and that is interested part in the biotechnology, because industries are interested in the secondary metabolites. Okay, maybe that is of antibiotics, maybe that is of the pigment, in many of the enzymes. Organisms are producing all these things during their stationary phase. Okay, and at the end of this, that will consider as a death phase. Okay, or decline. Organism will utilize all the nutrient surrounding to them, and that will be utilized by them. Ultimately, now it reaches to a certain plateau, and after that it will going to be down. So that is the death phase. Okay, so for this we have in science we have a lot of technology, we have a lot of techniques which is helping to make the organism in a steady phases. Okay, if we are interested in a certain organisms, those are producing their population, they are increasing continuously. Okay, so we are interested to put in into that particular phase. So by the help of various technique, you can use you can apply that technique, and your organism will be steady state into that particular phase. If you are interested to producing or interested in a secondary metabolites, you can stabilize them. Okay, and these techniques that will help us or help the industries to have the better product, to have the stable product during the growth phases. Okay, a part of this, in all these phases, various environmental factors are also affected, right? That is pH, temperature, okay, various type of the substrates which is present inside. Suppose if it is we are interested to utilize, or we are interested in amylase enzyme production. Okay, so we need to maintain the starch or the substrate concentration. If you can put it in the higher concentration, that is also affected to the enzyme activity. In the same time, enzyme concentration should be remaining stable. Once it is produced in a certain level, you need to continuously purify it. Otherwise, what will happen? A higher concentration of enzyme itself will inhibit the whole process of the fermentation, that is feedback inhibition. Okay, so we need to maintain all these phases, and for that we have a various type of the techniques. Okay, now in population growth studies, the growth curve of the microbial culture is showing you the 4 phases that you can see here also, that is lag phase, log phase, stationary phase, and the death phases. Okay, when microorganisms are cultivated in medium, they are usually grown in the batch culture or the closed system. Okay, so in the closed system, what will happen? They are acquire themselves with the environment, and they will utilize that nutrient and will producing their routine or required enzymes. Okay, because of no fresh medium is provided during the incubation, what will happen? Organism will utilize this all nutrient in a certain level at the end, stationary and death phase. Okay, so that is, if there is a no continuously nutrition is added inside, organism will complete their 4 phases of the life cycle or their growth phases, that will accomplished within a certain time period. The growth of microorganisms is reproduced by the binary fusion, that you are knowing is, right? 2 raised to n. Okay, so that is continuous processes occurring. Growth may be defined as an increase in the cellular constitution. Okay, so it lead to rise in a cell number. So as nutrient is available, organism will utilize it. Lag phase, acquire. Log phase, now what they will start to do is multiplication. Okay, so that is lead to rise in number. Now keep these things in your mind, that I am talking about 2 things together. One, that is increasing the population of organism. Okay, and second thing, they are producing your desired product simultaneously. You are providing a certain specialized substrate to the organisms, and they are providing you, or they are producing their desire or your desired product. Okay, so I am talking 2 things together. Okay, so what will happening? Individual cell will be enlarged, divided to yield 2 progeny approximately in equal size. Okay, so at the result, what will happen? Maybe if it is a closed system, it will be no longer. Okay, as nutrient will be utilized, because once what will happen, 5 things, 5-6 organisms are there. After certain time of period, 2 raised to, and so what will increasing their population, again they are increasing in their number. Okay, so what will happen at the end, all the nutrient will be utilized by all the organism, because there's a constant competition, constant battling for the nutrient, and all organism will utilize. Okay, so at the end what will happen, there is no nutrient in the media and population is higher. Due to that, the growth phase will turn to the decline and you will get the no growth or the less turbidity in the medium. So in same batch cultivation, in a batch flask or in the closed system, initially you will get a higher concentration, or and after certain time of period you will get the higher turbidity. But in the same flask, after certain time of period you will get the decline phase, the turbidity will be low, right? So that is due to the competition for the nutrition by the organisms. So what will happening during the lag phase? Microorganisms are introduced into the fresh medium. There is no immediate increase in the cell number. The cell number will be not increasing immediately. Okay, and therefore the period is called the lag phase. During this, what will happen, right? Organisms will start to acquire themselves with that particular environment, and here during this whole process there is quorum sensing is occurring. There is a two component theory. It's a two component theory done by the organisms. That is, organisms, those who are getting the information that some of the nutrient is available on the cell membrane or in the cell wall, organisms possess a signaling component. They are sending signals. They are trying to assessing whether where is the nutrient. Okay, they are getting, as they are sending their signals, some of the nutrient, some of the component is available. Maybe it is a starch. Okay, so as that signal reaches to starch, the same thing, that is quorum sensing, so it will do both of the things together, that is transmission and receiving. Both the things together done by the organism. Okay, so what will happen, as it will reach to the starch, okay, immediately that signal has been captured, again revert back to the cell wall, that starch or your desired component is there. Okay, and that signal again transmitted into the cytoplasm, that you need to produce a certain enzymes who will utilize this starch. So your desired nutrient is available into the medium. Okay, this whole process is occurred during this particular phase. During lag phase, what the organisms are trying to do, that they are transmitting their signals and try to find out where the particular nutrient is available, or where or whether there required nutrient in sufficient concentration available or not. They have to take a decision during this. Okay, as they gathered the information that there is a required nutrient is available, or their desired nutrient is available, okay, same signal has been transmitted to the cell wall component, and that cell wall component again transmitted their signals to the cytoplasm. So cell wall component have a two theories simultaneously. Once they are behaving as a transmitter, second time they are behaving as a receiver. Okay, and during these phases they are doing both the job together, and they are sending these signals to the cytoplasm, and all the cytoplasmic enzyme will be activated to utilize this particular nutrient which is available during the or surrounding the cell. Okay, so this is a two component theory which will be completed during the lag and log phases. As during the log phase they come to know that this nutrient is available. Okay, first of all, that what they will start to do, that they are utilizing their nutrient for their common growth, because ultimately their aim to duplicate themselves. Multiplication is their major aim, their motto. right? So what they will do is increasing their population. Okay, so during this log phase, what they will do is utilizing surrounding nutrient which is simplest. Okay, though they get the information that is starch is available, but what they will do is immediately utilize a certain nutrient which is surrounded to them and increasing their population. After that, while they are coming to the stationary phase, what they will start to do is producing a higher concentration of this particular enzyme, that is amylases. Okay, because now all population is increasing, everybody is satisfied by the nutrient. Okay, now they are interested to do their secondary activities. Okay, primary activity, that is the increasing their population, that activity has been done. Now they are in a sufficient amount, they are in a higher population. So what will happening, that all organism will start to produce amylase enzyme. Okay, and they will utilize all the nutrient or the starch surrounding to that. Okay, so two component theory is helping organisms to make their or to increasing their population, or to make them in stable during the stationary phase, and to have the increasing their population during the log phase. Okay, so two component theory is very important during the growth curve or during the growth cycle. Okay, and quorum sensing is playing a very important role, that is organisms are sending their signals, okay, and they are receiving it. Okay, if there is no any signals or receiving, what will happen? Suppose organisms are in a certain environment, they are not getting their nutrient what they require. What will happen during these phases? If organisms are there in some of the region where there, suppose organisms are amylase producing, okay, but we have putting into the mercury environment, some of the mercury or heavy metal containing environment, what will happen? Cells will die. Anything? According to the growth phases, what will happen? We won't get these phases, right? Instead of that, what will happen? Organism will initially, they will start to acquire themselves with the environment. Okay, lag phase to hona hi hona, right? And as it will not get it, what will happen? Immediately decline, right? They will start to die. They will that is decline. But in industries, what they are interested to do? Stable growth phases. They need these growth phases for a longer time period. If something will happen like this, it will cost effective to them. Okay, that will not beneficial for the industry, as well as spending lot of money for that. That will not good thing, right? Economically, industries have a so what will happen during this? We need to stabilize their growth phases. Okay, so for that again two theory is there. One, that is chemostat. Second, that is turbidostat. During the growth phases, if continuously population is increasing and stabilized, okay, turbidity is increasing or turbidity will be stabilized, that will be turbidostat. In chemostat, you are chemically defined media, you will make it constant. Okay, chemically you are adding whatever the nutrient that you are adding it, that will be stabilized, or that will be in the same stage or for a continuous concentration. Okay, now during the exponential phase, microorganisms are growing and dividing maximal rate possible with the genetic potential, right? According to that DNA that you are knowing it, that is lag phase, what happening during of the DNA during that particular phase. The same time into exponential phases, what will happen, right? The rate of the growth is a constant during the exponential phase. The microorganisms are dividing and doubling in the number at a regular interval, because each individual divide at a slightly different moment. the growth curve rises smoothly rather than distinct jump. It will not suddenly like this. Okay, what will happen? Each first organism who is divided after 20 minutes, okay, it will reach to the stationary phase. At that time, second organism will go to the lag phase. Those who is newborn, that will go to the lag phase. Okay, as divided new two organisms that will reach to the stationary phase. At that time, first organism, again those who newborn, will go to the lag phase. Okay, so that is continuous process. Due to this, it will slowly increasing. Okay, and we will have a long or prolonged log phase. Okay, so these particular phenomena of the organisms that we are going to use it later on, that is how you can use these specific phases for the betterment of in industry, how you can apply these growth phases. Okay, exponential growth is balanced growth, that all cellular constituents are manufactured at the constant rate. Okay, to if nutrient level or other environmental condition is changed, what will happen? Growth will be imbalance, as I told you. Okay, suppose instead organisms are require starch as a whole sole source of the nutrient, and instead of that you just give them heavy metal, what will happen? That is unbalanced and you will not get the phases. Okay, immediately what will happen? Initially, as you will put it, they will not die, they will start to adapt it, and adaptive physiology is a different story. An organism will adapt this type of the environment, but later on it will take a longer time period. Okay, but for routine you need to understand that is unbalanced growth. Okay, organism will not survive for the longer time period. Okay, so this growth during which the rate of synthesis of the cell component varying relative to one another until a new balanced state is reaching. What will happen during this phase is, if organism will not get it properly, okay, the growth phase will be changing. Okay, this response is readily observed in a shift up experiment in which bacteria are transformed from nutritionally poor to the rich one. Normally that what you are doing in your practicals also, that initially you will put in them into the enrichment media. Okay, for the fermentating media, initially you will add your sample or 1 gram of the soil sample or your desired organism into the enrichment media. After that you will add this growth 5%, 1% to the fermentative media. Right? What you are doing it, initially you put it into the enrichment and after that you will add it into the fermentative media. Right? Why you are doing all this? Why? Yes, you want to eliminate the lag phase. Okay, what organism will doing during this? While you are putting into the enrichment media, what organism will do? They will acquire with the environment. Okay, so less log phase and you will have prolonged log phase. Lag phase will be most or least. Okay, and you will get the prolonged log phase. Okay, maybe if you are interested to do you are particularly interested into the secondary metabolites. Okay, what you will do is again minimize this. Okay, and prolong stationary phase, minimum lag phase, that you already done it into the enrichment media, and you will put the minimum log phase, and after that you will have the prolonged stationary phase. So your desired product will be in a higher concentration. But how you can get this? If it is prolonged log and if it is prolonged stationary, how you can get it? That is with the help of these two, right? So balanced and unbalanced growth is very important during the phases, and that is needed in the industries. Okay, the cell first constant new ribosomes to enter their capacity for the protein synthesis. These followed by increase in the protein and DNA synthesis. Okay, ribosomes will be acquired and ultimately that will DNA synthesis will be higher, so you will get the most population during the exponential phases. Okay. If it is a nutritionally defined concentration, what you will get it? Balanced growth. And if it is not undefined or not proper nutritional component are not defined properly, okay, what will happen? You will get a different growth pattern. Okay, so normally that we are interested to go through these phases, that is in step by increasing into the growth. Okay, unbalanced growth also result in a bacterial population is shifted down from the rich medium to the poor. The organism may previously have able to obtain many components directly, okay, from the medium, but as you will put it into the poor medium, now what will happen? Their ability to utilize the nutrient that will be lost. Initially you put them into the rich media, okay, that is all the component, all the nutritional availability is higher in the concentration. What will happen? Organisms cannot utilize it, and they are utilized it properly, and they will have the best growth pattern. But once you have kept them out and put it into the poor medium, what will happen? Their ability to utilize the nutrient that they will be lost. Okay, and now what will happen? They are wasting their energy for the forums. Okay, they are sending their signals to outside. Every time they have to spend their energy to find out that our required nutrient is available or not. Okay, our required component are available or not, and if they are not getting it, again what will happen? Signals will not be captured by the cell wall component, and what they will say to the cytoplasm? No nutrient. Okay, so they are wasting their energy but getting nothing. Okay, they are sending their signals but they are not receiving anything. Okay, so for that again they need to send their, they have to spend their energy, and due to that what will happen? Again organism themselves will be start to die. Okay, as you told me that what will happen if the organisms are, I put the organism, those who require the starch, instead of that I put it into the heavy metal, what will happen? Die. But how they die? They are sending their signals, okay, from the cell wall. They are sending their signals whether our desired nutrient is available or not. Okay, so to send the signal they have to spend their energy. Okay, but that energy will be wasted because they will not receiving anything, because there is no nutrient available. So what are happening during the unbalanced growth? That you will not get the proper growth pattern. Okay, so consequently cell division and DNA replication continues after the shift down, but net protein and RNA synthesis will be slow during the phase. The cell becomes smaller and recognize themselves metabolically unit that they are able to grow again. Then balanced growth is resumed and culture enter into the exponential phase. If the sufficient nutrient is available, organism will go into the exponential phase. This shift up then shift down experiment demonstrate that microbial growth is under precise coordinated control and respond quickly to change the environmental condition. If environment condition will be changed, every time what will happen? Organism require log phases, and that is prolonged. Okay, but if you will put them into the defined environment and provide them, for sending the signals, it is not necessary that for starch they need the nutrient from starch only. Initially, if the environment, or if it is a closed system, or if it is a batch cultivation, not only starch, other components you already have been added, that is peptone, glucose and other things that you have been added. Okay, so that signals transmission procedure, for that they require the nutrient or they require the energy that can be supplied by the utilization of this peptone, glucose and other things. Okay, but if it is something like no one of the nutrient is utilized by the organism, some of like this heavy metal contaminated region, organism cannot be survive, or they cannot synthesize their originally or primary metabolites, that is their primary enzymes, they cannot be synthesized. Okay, so due to that, what will happen, that organism will be die. When microbial growth is limited by the low concentration of the required nutrient, the final net growth or yield of the cell is increases with the initial amount of the limiting nutrient present. This is the basic of the microbiological assay for the vitamin and other growth factor. As I given the example of amylase and heavy metal, in the same way you can put it with the vitamins. The rate of growth also increasing with the nutrient concentration. The shape of the curve seems to reflect the rate of the nutrient uptake. If they are utilizing the higher nutrient, what will happen? The phase will be prolonged. Okay. If minimum acquisition time, minimum time to acquire themselves, smallest or the least leg. Okay. As they are already acquired with the environment, they will immediately go into the prolonged phases. Duplication of the cells, higher concentration, that you will get it, the more turbidity or high population. Okay, in the same phase you will add, now the organism is entering into their stationary phases and they require, you are interested to produce amylases. Okay, so continuously if you will provide them a starch, now organism will be in the same growth cycle. Okay, so now we are coming into that part also, that is in growth phases we are also interested to utilize the organism in the same phase of the cycle, and that is known as, anybody? If organisms are in the same phase of the growth cycle or synchronous. Okay. Okay, so synchronous culture, if we are interested to utilize the organism in the same phase, that is what industries are doing, lag phase, log phase, stationary and decline. Okay, so they are interested in these two phases. Okay, not in this, not in this. Okay, so for the synchronous culture, we are in synchronous culture, that is defined as the organisms are in the same phase of the growth cycle. Okay, so if we are interested in a stationary phase, that all organisms will produce secondary metabolites. Okay, and that secondary metabolites, our example, that is with the amylase. So what we need to do is continuously provide, if the organism will go through this phase, if they are entering into this phase, we need to continuously add starch. Okay, what will happen? All organisms are now in a stationary phase, they will provide or they will produce secondary enzymes, that is amylases. Okay, so for that, what the nutritional, that what is the major component they require? Starch, right? So what you need to do is continuously provide, organism will be in the same phase of the cycle, they will utilize the starch and continuously will produce the amylase, right? So you will get a prolonged phase because you are providing a nutrient to them, so they won't get to decline because you are providing continuously a starch to them. Okay, now for this we are not with the only with the this enzyme, but we can do it with the many other phases. If it is some of the vaccines, we are also interested to do with the synchronous culture, that the same organisms are in the same phases. Okay, now in the stationary phase, usually attained by the bacteria at the population level of around 10⁹ cells per ml. Other microorganisms normally do not reach with such high densities. Other protozoans and algae cultures are often having a maximum concentration about 10⁶, but bacteria can reach up to the 10⁹. Okay, microbial population enter stationary phase for the several reasons. One obvious factor, that is the nutritional limitation. If essential nutrients is severely depleted, population growth will be slow. If nutritional will be slow down or will be utilized by the all populated organisms, all the organisms which are there into the batch, what will happen? That will be organism will go into the slow phases. In the same time, if it is high populated into the batch cultivation, scarcity of the oxygen, okay, they will face the oxygen scarcity. Oxygen is not very soluble and may be depleted so quickly, so that only the surface of the culture have an oxygen. Okay, rest of that will be in the, what will happen if it is a higher population, these region organism will get the oxygen. Those who will be in the down, because of the high population, they cannot get the oxygen properly. Okay, so in starvation, positive experiments of the bacteria do not respond with obvious morphological changes. Okay, if it is a starvation condition, what will happen? Organism will not get the proper growth, and after a certain time period you will also observe the certain changes in the organism's pattern. Okay, they increase in peptidoglycan can cross-link the cell wall strength. A DNA binding protein from the starved cell, a protein protects DNA. So clearly these considerations are of the great practical importance in the medical and industrial microbiology, that organisms, some other bacterial pathogen can be virulent with this certain curve if you will not provide them a proper nutrient of, or maybe with the changes in the phases. Now in the dead phase, nutritional